Very good morning one and all. Once again welcome to our new topic artificial. Okay, मैं फिर देख के ही कर लेता हूँ, छोड़ दो कोई नहीं.
मैं कर रहा ना इधर से, बस आप सामने देखो.
Very good morning one and all. Once again welcome to our subject artificial neural network, and today we are going to discuss very important topic, feed forward neural network. So far we had a lot of discussion about how the single neuron is going to be work in two phase, right? How it is going to be work as a classifier. Now we will talk about the multiple neurons and multiple outputs, and overall we will see that how the neurons are going to consider the inputs and what is the outcomes of each and every neuron, how they are going to be multiplied in the hidden layer, and finally what will be the output of hidden layer that will goes to the output layer, and finally we will calculate what exactly the error is. So that's what we are going to discuss in our today topic, feed forward neural network, right? And at the end of this session everyone is going to be understand that how the complex function, in the complex function, that's what I mentioned here also, how the propagating the input data through the multiple layers in the hidden, and finally we will get the output. This is the objectives and some outcomes. Now just now we had a discussion about the feed forward neural network. It's a type of artificial neural network that everyone knows that what are the applications, why we are going to use this feed forward neural network is for pattern association, identifying that, to analyze the pattern classifications, the pattern mapping, the clustering. The various applications are there where we can use the artificial neural network to identifying something. One of the example I am going to consider here, pattern classification. In each and everyday life, suppose we have one image, in that particular image we have various type of birds like cat, dog, bird, like that. Various animals are available, right? And being a human being we can identify very easily, but for a machine it's very difficult task while seeing the pixels value, how it is going to be categorized, how the neural network is going to categorize that yes, this particular image belongs to the cat or dog or bird. These are the few real-time challenges we have, how the machine is going to be recognized. That we will see that what is the input, how the inputs are going to be considered in the hidden layer, and finally we will see what is the final outcome with the error. Before moving with that, so few of the steps, the fundamental steps I am going to discuss in the feed forward neural network is nothing. First, initialization of the values. It means that first of all, whatever the complex network is given, you should analyze it, what are the weight values in given, what are the bias values, what are the inputs, the entire outcomes, whatever in the network you are expecting, that is available or not. We should initialize it, those values small. Now the second thing, the forward propagations, if you will observe it, forward propagation means what? The input data you are going to feed through the network. And each and every neuron is going to calculate their weighted sum of the inputs, and that we are applying the activation function. We know that each and every neuron is working in two phases. First the summation, and the second one is activation function. That's what. And that outcome we are going to add in the result section for next layer. This process will repeat for each and every neuron whatever available in the hidden layer. And finally we are going to calculate the error at the last step. These are the three steps we are going to follow for the feed forward neural network. What is the how we are going to calculate error? Difference between the actual output and the desired output. That's it. With the one example I am going to discuss all these three steps in details. These are the algorithms. That's what just now we had a discussion about. First initialization, then input layer, receive the input data from X. The second, the forward propagation through the hidden layer, linear transformation, summation, the first phase. That's what I'm always mentioning, that each and every neuron is working in two phases. So first one is this summation, and the second one is activation function, this one, second phase. The same step is going to be repeat for all the neurons whatever available in the network. And the same thing is output layer. In the output layer also the linear transformations and the activation function we are applying, and finally you will get the output there. These are the mathematical equations or functions, I mentioned it there. Now we will apply all these functions in the numerical. And before moving with that, all of you are familiar with this single neuron, the summations, the first phase I'm always talking, the second phase, the sigmoid function. That sigmoid function I'm going to use in the neural network. What is that network? 1 upon 1 plus e power minus x. X is nothing, whatever the output you are getting, you can write it here small y also. It's just notation. And as per this diagram, I mentioned it there, net output, summation of all the inputs with respect to the weighted weights, these net values. This sigmoid function I am going to use for each and every neuron in our upcoming numerical. This is the formula. Now this is the complex network. We are going to consider how we are going to calculate the outcomes from here. Here I consider two inputs. All of you, it's very clear in the diagram, the x1, x2, and with respect to that two values are given 0.05 and 0.10. I told you that at the input layer we have two inputs, at the hidden layer also we have two hidden nodes, h1 and h2. What is the input of h1? x1 to h1 and x2 to h1. There are two inputs, as these arrows are going to be mentioned there. What about h2? In the same way we have two different inputs here also. One input coming from x1 and another input coming from x2. These are the two hidden nodes, and with respect to these two hidden nodes we have two outputs, y1 and y2. So we can call as multiple input and multiple output. So one by one we are going to see how these values we are going to calculate. But before that, all of you should know one thing, the basic fundamental of this. Suppose this is the neuron, this h1 I am going to consider. You can consider any neuron. What is the equation of this neuron? Here I am going to write it. How you will see that what is the final output of this h1. Now what is the input here? This x1, and with respect to this x1 the w1 is the input. So I will write it here, x1 into w1 plus what is the another input and from where it's coming, x2 into w2. So I am going to write it here, x2 into w2 plus my bias value, and bias value is b1, that I am going to mention it. Very simple equation, only additive equations I mention here. In the same way I can write it for h2 also. What is the equation for that? x1 w3 x2 w4 plus bias value b1. This simple equation I am going to use to calculate the value of h1 and h2 in our network. And what is the sigmoid function? That I already told you, that 1 upon 1 plus e power minus x. X is nothing, this is the output of this, or you can write it here h1 and h2. So let's start. According to the diagram, these both inputs are given, x1 and x2, both bias values are given, both targeted values are given, t1, t2, 0.01, 0.99, and at the first level w1, w2, w3, w4 for all four weight values, and at the second level w5, w6, w7 and w8. All these values are mentioned in the diagram. Once we initialize those weight values, as per the algorithm, our first step is initialization of all these values, and this is the initialization. All these values are given. Now we will move to the first step, and according to the diagram I told you that what is the first equation of our h1, x1 w1, x2 w2 and bias value, and all these values are already mentioned in the diagram. What is the input? x1 that is nothing 0.05. According to the weight with respect to input 1, 0.12 plus my input is, second input is 0.10, my weight values is 0.20 plus bias value is 0.35. When you will multiply, when you will add, you will get this outcome 0.3775. This is the first phase of our neuron. If this is the neuron, we done so far summation process, and summation value we got it 0.3775. And at the second phase, what you are doing, you are applying the activation function f. And what is the activation function here? Sigmoid. And what is that formula? 1 upon 1 plus e power minus x1. Here instead of x1 we are giving the notation h1 value. What is this h1? Is nothing, hidden node 1. What is the value we got it here? If you will put this value 0.3775, we have scientific calculator, we can calculate this value. So finally you will get the output of h1 is 0.593269992. Might be few of the students, they having some doubt why I am writing 7 to 8 decimal values. That I will discuss when we are coming for the backpropagation, when we will discuss about the backpropagation process in the next class. But remember it, we should always consider minimum 7 to 8 decimal values so that our output is going to become absolutely nearer to whatever we are desiring. In the same way, we are going to calculate the H2 also. And what is the value of H2? That we know that x1 into W3, x2 into W4 and plus bias value. And all these 5 values we know it. According to the diagram, if you will see here, I mentioned the H2 is x1 value we know, W3 we know. These both values is already given in the diagram. X2, W4 is also given and plus bias value is also given. If you will put all 5 values, we will get the some y function, y values. And when you are going to apply this 1 upon 1 plus e power minus y, when you will apply the activation function, you will get the final y dash. And what is that y dash? Is nothing, H2. This is my H2. What is my value? 0.596884378. So finally at this level we got it, these 2 values. Here I am saying that this H1 values you got it and this H2 value also we got it. How x1, x2 are there? 0.05, 0.10. In the same way we got it, H1, H2 is 0.5932 and 0.59688. So now according to this diagram, these 2 values will work as input of this neuron and we are going to calculate the output of this neuron. So if you are going to calculate the output, so it means that we are going to calculate this y1 and this y2. Same fundamental I will apply for this also. What is my equation of y1? h1 into w5 plus h2 w6 plus bias value 2. In the same way, if I want to calculate for y2, what is my y2? h1 w7 plus h2 w8 plus bias value v2. Simple equations, whatever the fundamental equations I mentioned for h1, h2, the same fundamental equation I mentioned for y1 and y2. Just now we calculated this h1 and h2 and the weight values are already mentioned, w5, w6, w7, w8. Bias 2 value is nothing, 0.60. Again all these values are given. The same sigmoid function I am going to apply throughout the network. Now have a look here. The same equations according to the diagram I mentioned there, h1 w5, h2 w6, b2 and all these values we know. When you are going to solve it, you will get 1.105905906967. And when you will apply the activation function of the same value, what is the output of this y1? Is nothing, that's one. What is your final y value? Y value is nothing, 0.75136507. In the same way, the same fundamental equations, so final output you will get it 0.7729284665. With a very simple equation, with a very simple calculation, we calculated our h1, h2 both hidden values, and with respect to output y1, y2 we got it. Now the last step, once you know the value of y1, y2, how we can calculate the error? What is the formula for error that we know? Summation 1 by 2, target minus output square. Targeted value, we know that according to the diagram 0.01 and 0.99. And what are the y1, y2 values we got it? That also we know. Just now here we clearly mentioned that 0.7513 and 0.7729. All these four values you just put in this particular error formula, you will get the error. According to the error 1, targeted value is 0.01 and my output value y1, that also we just now we calculated, plus 1 by 2, targeted value T2 is 0.99 and H2 value is this one. When you will solve, overall 0.298371109, this is the error we got it. So according to this diagram, we have seen clearly what exactly was the input and what exactly how inputs are moving to the hidden layer and what kind of information will pass from input to output, and finally the way how we are calculating the error. This is entire about the feed forward neural network. I mentioned few more examples for here. All of you are just exercise point of view, I given 2 or 3 so that you will get the clarity. Again here I consider 2 inputs according to the diagram x1 and x2, 2 hidden node h3, h4 and 1 output node, that's it. Previously I mentioned 2 output node, here I mention only 1. All the weight values are given, inputs values are given, so what you are going to calculate, this h3, this h4, and finally we will get the outcomes. I will show you. I will go with a small glance so that you will get the clarity about again once again. Now if you will see, I am going to calculate here aj value a1. What is the meaning of a1? I am going to calculate here h3 function that I am going to divide it here. The first phase is a1. What is that formula? w13 into x1 plus w23 into x2. Bias value by default, if they mention, well and good, otherwise you can proceed like that. So bias value they didn't mention, so we are not going to consider anything here. Now when you calculated the summation, what the values you got it, 0.755. When you applied the activation function here, the final value is 0.68. This is nothing, this is your y3, means hidden output. In the same way we can calculate for a2, w1 for x1 plus w2 for x2, all these 4 values we know, and finally summation 0.68. when you will apply the activation function, sigmoid function, you will get this particular value 0.6637. So y3 we know, y4 we know. In the same way you can calculate a3 in fact. Once you know these 2 values, easily we can calculate this y5. In the same way, both the values we already calculated. First phase of the output, when you will apply the activation function, you got it 0.69. What is the value you got? 0.69. It means that what is this value is nothing, 0.69. And as per the statement, if you will see what is the expected outcome, 0.5. Then what will be the error? Error formula also we know that once you are going to subtract both of them and you will make 1 by 2 square. Simply here they mention that 0.5 is our target value, 0.6 now our module got it, and 0.19 is the overall error. How this error we are going to resolve and how this error is contributing each and every weight values, that we will discuss in the next class. So this is the example for all of your exercise. So kindly note it down and do this exercise at home. If anyone have any problem, we will discuss in the next class. Thank you. Thanks a lot.